Hi, my name is Nizam Ercan and I'm an electrical electronics engineering student at Bilkent University, and this is my Physics 102 term project. In this project, I will put a charged object between two parallel plates connected to a power supply and measure the tilt angle for different voltage values to calculate the charge of the object. We can express the electric potential across two parallel plates with the electric field and the displacement, as you can see that the electric potential is the integral of the electric field with respect to the displacement. We know that the displacement vector is anti-parallel to the electric field vector. Therefore, we can simplify these expressions as E times x. We can use this information in a system like this, where an object with mass m and charge q is hanging between two parallel plates. We know that tangent theta is equal to the ratio of the electrical force applied to the object to the weight of the object. We also know that the electrical force is equal to the charge of the object times the electrical field applied to the object. From the previous part, we can express electric field as V over d, d being the distance between the plates. And by combining these information, we get Q is equal to tangent theta times m times g times d divided by the voltage. I can use this expression in the experiment to calculate the charge of the object. For the experiment, I created the previously mentioned figure in real life with two parallel plates covered with aluminum foil and hang the charged ping-pong ball with small mass between them. You can see the properties of the ball and the plates in table 1. I started the experiment by applying an increasing voltage from 0 to 30 volts and measured the tilt angle for different voltage values, as you can see in table 2. Then I used these angles to calculate the electrical force applied on the charge for different voltage values and found some estimates for the charge of the object for different voltage values in table 3. When I take the average of the charges I calculated from the experiment, I got 6.62 times 10 to the power of minus 6, which was only 5% off from the actual charge of the object, which is 7 times 10 to the power of minus 6. This meant that my results and theory match with each other. Also, when I plotted the electrical force with respect to the voltage values, I observed that the electrical force was increasing linearly, which is what I was expected as I knew that F is equal to Q times V divided by D. When I drew the line of the best fit and calculated its slope, I got 8 times 10 to the power of minus 5. I expected this value to be Q divided by D. When I multiply this value by 0.1, which is D, I get 8 times 10 to the power of minus 6. This value for Q also matches with the actual value of Q, which is 7 times 10 to the power of minus 6. In the end, I was able to calculate the charge of the object from the tilt angle for different voltages. I also managed to show the relationship between voltage of the parallel plates and the electric force applied on the charge of the object, which meant that I achieved my aim for this experiment. From the tilt angle of the object, I estimated the charge of the object with approximately 5% error. I also learned how to use multimeters and DC power supplies and learned the effects of an electric field on charged objects. There are some possible reasons for error in this experiment. First of all, I checked all of the voltage values between the parallel plates with my multimeter in all of the steps, so I am sure that there is no error due to the parallel plates. However, some of the charges in the object may be discharged until the end of the experiment, which can result with measuring a smaller, inaccurate angle. Also, it is possible that some human error have also affected the experiment, since measuring the distance of the end of the rope to the normal for a floating object was a little bit difficult. This can cause some discrepancies, which can explain the 5% error in the result.